Okay, I start the presentation now. Hello, everyone. My name is Mahima Gehlot. As you all know, I'm the Chief of Engineering Center of Mission 211. And my presentation over here is about lumen habitat, which stands for the light in Latin, and the Vajra space station. That's basically about the lunar habitat and vigilant asteroid judgment and research array station. I want to focus more on planetary defense as well, because like I mentioned earlier as well, my background comes from near Earth asteroid research. I'm a co-lead for Space Generation Advisory Council's one of the project of near Earth asteroids, and I'm also working with world's biggest analog astronaut mission as research coordinator. So that's all about me and my topic. I'm going to start the topic with a little bit of introduction, what I'm going to talk in the whole segment. Just give me one. So I'm going to talk about the design protocols and even the duties, missions, and what sort of experiments we are going to do and why what was the reason to include the whole observatory for finding an asteroid over here instead of using a Earth-based observatory. So when it comes to the project itself, like humanity is moving for self-sustaining habitats and planetary defense capacities over Earth. I want to build all those things on Moon as well. And the Lumen Habitat and Vajra Space Station propose the same idea for supporting the long-term human habitat over here. We are talking about 4 astronauts monitoring and mitigating of asteroid threats to Earth. Like we already know how much bigger trouble and a smallest asteroid could become. So that's also one of the target for the habitat and pioneering the in-situ resources utilization for sustainable living and serves as the big deep space observatory, which is your Vajra. And it's going to be deployed by the help of SpaceX Starship. So the size of the whole habitat will be around 8 meters, and three different modules could be part of it. But I'm going to show you the very base of it, the very first module, which is going to be part of the long-term mission. But before I show you the module and everything, I do want to tell you why we are talking about Moon itself. Because when it comes to an asteroid tracking, Moon serves as a very good opportunity because of the clear sky, no atmospheric hindrance, and low gravity also allow us for easier launch for any deflection mission from there instead of starting everything from the Earth itself. And Moon also serve as a best test bed for Mars missions and even our deep space exploration missions, and including near Earth objects as in research because NEO is a problem. Most of the time, we don't talk about planetary defense, but we know how much big trouble a smallest asteroid, even some of the bigger ones, one of the asteroid even wiped out the dinosaurs. One of the threats, it might be in 2029 or 32, lingering around us. So we need to talk about NEO as well over here. And moon positions allow us for early detection and faster response. Like laser and lidar system can be used for asteroids and like detecting and with a very high precision. When it comes to deflection methods, like I'm also proposing some deflection methods. So kinetic impactors, gravity tractors, and even using direct energy. I'm talking about nuclear weapons over here. So that can be a very good option when it comes to deploy everything from the moon instead of talking from the Earth itself. And this is the whole picture of the model suggested by Habitat Mate for the lunar mission. One is if you see over here, the very first thing is the launch center. Then comes your main station, health facility, greenhouse, and engineering facility, which I'm the chief of, and even power station, solar farms, and all those things. So let's move on to the whole station itself. The Lumen station or Lumen habitat over here has three different levels. On the top, we will be having our observatory, which is going to work on finding asteroids, and the middle one can be for the workstation for planting our all greeneries and all those things for food. And even the middle section is for the astronauts to have a rest over there. And the bottom one could be served for the 3D printing, designing, and all the research work. So over here is our research center. This one will be the resting area for the astronauts. And the serve as an hydroponic center and aeroponic center for the whole space farming. And the top one serves as an observatory. The main idea behind observatory could look like this, where we have different centers to not only precisely mark an asteroid, but also understand that what sort of technology will be useful to detect them, to mitigate them, and even if required, destroy them. So the purpose of the observatory is this, and then comes the whole hydroponic center where we are going to grow all the requirements within the space station and habitat instead of going and bringing everything from the Earth. So the hydroponic center could look like this, and that's a whole just an idea which is in discussion for now. But when I talk about the mission objective itself, the very primary objective is for planetary defense. And like I'm keep on focusing on planetary defense. Vajra Array is gonna talk about real-time asteroid tracking, even for testing the kinetic impactor technology and develop laser-based deflections because asteroids are having many minerals and even some water. So if we can actually evaporate some of the materials, it might help to deviate the trajectory and all those things. And when it goes to sustainable lunar living, a closed loop life support system like oxygen, water, and food recycling over there. 3D printing with the lunar regolith, not using any construction material from Earth, but using the in-suit materials like using the resources on the moon, that is your regolith, which we can use for 3D printing. Nuclear over here could be initially about the fusion, but in future we can also develop some sort of smaller nuclear fission reactors for better energy resources. And till then, we can use nuclear fusion reactors and solar hybrid power reactors, basically solar panels and all those things. And then it goes to the scientific research. Lunar base is a very good start for low gravity biological experiments like plant growth, human health, and all those things. Deep space astronomy also, like Moon's far side, is a radio silent place where it could be an ideal for any telescope to put over there. And like on Earth, we have a very good amount of light pollution. So over there, we might have a very ideal place for any radio options and radio astronomy over there. Lunar geology and mining feasibility as well, like helium-3 or even the rare materials, rare metals on the lunar surface. Secondary objective is the spin-offs. Whenever we start any mission, the spin-off is one of the best thing when it comes to any mission. So over here, we can talk about compact nuclear reactors and even water recycling things, which can be good for the remote places on the Earth, human-machine collaborations like AI assistant asteroid monitoring system, and interplanetary internauts like relying on Mars missions is going to help us for the Mars missions as well. So let's go on to the internal design for now. There will be three different levels for the whole habitat. The first level talks about the wellness and recreation, where we are talking about meditation, relaxation zone for an astronaut, micro gym, and even entertainment hubs. And hydroponic mini garden could be over there for small scale of plant growth and even for fresh snacks over there. The second level goes for the workspace research, where we are talking about the asteroid research, spectroscopy tools, 3D asteroid modeling station, which will be part of the upper section of the habitat, asteroid workstations like adjusting decks, AI assistant research tools, 3D printed lab for tools, replacement parts, and psychological aid like personality, all those softwares to analyze what's going on with the astronaut for the 1 week's whole mission, and even converting CO2 to oxygen. That MOXI unit is also part of the second level workspace and research center. Then comes the third one, where mostly is the middle section, where our astronauts are going to have their soundproof sleep ports, even for gravity problem. We have adjustable gravity simulations for better sleep. And as we all know, we are far from the home, so private communication booth as well for the secure Earth call. Mental health monitoring system is also required because we are in a close confinement, which requires a huge amount of monitoring system for the health of an astronaut over there. So mental health monitoring station will be part of the resident privacy station for an astronaut. So what sort of technologies I'm going to use for the mission itself? Just going to so lumen habitat instruments include life support monitoring system like atmospheric mass spectrometry, where we can detect around zero point 0.1 ppm molecules of carbon monoxide, NH3. Water quality sensor arrays, which can use for pH level monitoring, conductivity, microbial loading. And like moon is a good source of different resources, so geological tools will be part of it. Elemental analysis for regolith and 2 meter depth capability of core drill for spectrometry of the moon. And like health and safety is also one of the points. So portable ultrasounding device with powered with AI for diagnosing and even for assessing the injuries, and airborne particular monitor because like moon dust is one of the problem over there, so we need to monitor that as well. For communication system, we can use K-band, phase array, even lunar GPS constellation systems we can deploy, and far side quantum computing modules can be also part of it. So when it comes to the very base of it, MOX, oxygen generator, 3D printers, VR therapy systems for stress relief for an asteroid, AI mental health assistant, and asteroid analyzing tools will be part of the mission. So, like we all need food, so does an astronaut. So we will have like vertical aeroponic farming system for 8 layers of grow system where 2 meters of 2 meters 2 square meters of footprint can actually convert into 12 meters of equivalent area where we can have 8 different layers of the growth system, AI optimized LED spectrum turning, even like we can produce green leaves, microgreens, and even some tuber crops and LG photobioreactors for cholera production and like all those things, and microprotein cultivation, growth fungal based meat substitutes. Why I've used meat-based substitutes? Because I'm talking about the vegetarians on the space as well. Like we all know, most of the food includes non-veg food as well, and I come from a vegetarian background. So vegetarians and vegan have a hard time when it comes to an astronaut mission. So I want to try what we can grow over there and what we can do best for the vegetarian astronauts like me, and utilize inedible plant matter over there as well. So in situ sources will be like CO2 converting O2 via amoxide, regolith for 3D printing, recycled water and plastic, and solar energy as we have a plenty of solar energy on the moon. When it comes to what we are going to bring from the Earth, seeds for hydroponics, 3D printed filaments, and VR therapy softwares for an astronaut's mental health, and specialized asteroid research tools. So when it comes to the location, I did find two of the candidates very good for the whole mission. One is the Shackleton crater, which is in the southern pole of the moon. It has a very like very good place when it comes to sunlight, like for solar power. It's also equipped with a lot of water over there. It's in the ice form, but we can find drinking water and which can also be used for fuel and oxygen. Clear line of sight to Earth and the deep space mission as well. But when it comes to the problem with Shackleton crater is rugged terrain. Landing is very challenging, so it will become a problem when we are going to land with our instruments over there. And it is going to be extremely cold when it comes in shadow 230 degrees. It's actually a problem. So these things we have to take care of. But it is very best when it comes to energy, resources, and science. So that is one of the most important part for me, and that is why I've opted for the Shackleton crater. But the second one was Malapret Mountain, which is also in the southern pole. Over here, sunlight is also available around 90% throughout the year, direct Earth visibility and low radiation, and which can help us in the shielding of the moon's mass. But at the same time, limited water access, then Shackleton crater. Backup suit is a good option for Malapret and for fewer resources. We can try for initial start for that there, but not for a long-term mission. So when it comes to location, for me, Shackleton is one of the good option. Then comes the management of the whole mission. So over here, we will have a faculty chief, engineering faculty chief, which is me. And then under me, there will be two system engineers, asteroid researchers, and doctors. The qualification and the requirements, roles, and responsibilities are as follows for everyone. Like the faculty chief is going to oversee all the operations, ensure crew safety, and for the success of the whole mission and control the missions thoroughly. The responsibilities also include the final decision making for habitat operations, managing emergency tools like evacuation and system failure. My daily task includes like morning briefing with the crew, reviewing resources level like oxygen levels and all those things, and approving any asteroid research priority if it is there. So the second one is about the asteroid researcher, which is going to be one of the lead scientists of the mission itself. So they had to study the asteroid samples, identify resources like water and metals over there, and document the findings. They have to report to the faculty chief, and the responsibilities also include operate spectrometer, microscope, and 3D modeling. Also publish the reports for the mission control and Earth lab. The daily task involves analyze asteroid sample, update the digital minerals, the whole database for the mission, and test the regolite-based manufacturing as well. So when it comes to a system engineer, which is also going to be the technician for the mission as well, so it had to be like a lead over here who can maintain the life support system, power and critical machineries. And the responsibilities include monitoring the oxygen the generators like water recyclers, and even solar and kilopower systems, repairing 3D printers if required, any drone which we would use for the monitoring in future, and VR equipments optimizing energy like prioritizing oxygen generation during crew sleep. Daily tasks also include run diagnosis of all the systems, replacing air filters for the printer or nozzle, for printer's nozzle, and like train crew or anyone who required for emergency tech protocols. Any new astronaut, he has to train for all the technical protocols. Then comes the doctor. Doctor here is going to be also a psychologist, dual role where he can ensure crew's physical and mental health in the isolation. He can monitor crew's vital systems like wearable tech analyst. We can have a wearable devices for them and can perform emergency procedures like sometimes an astronaut might feel not well, in case of sutures, IV requirements, trauma pods, oversighting it everything which includes first hand or like first aid for an astronaut, managing pharmacy and 3D printer, pharmacy 3D printers. Also, it has to conduct like VR therapy sessions for all the astronauts, meditate conflict via unity dinners. Daily tasks involve reviewing overnight biometric alerts, 101 mental health checkups for each and every astronaut code group. It has to host the group mindful events like low gravity yogas and all those sessions as well for the betterment of an astronaut's mental health. So when it comes to astronaut training, we are going to talk about habitat systems where like they had to train for the life support, oxygen and carbon dioxide balance system, water recycling, lunar 3D printing for emergency repairs and with the regolites. So every astronaut had to be aware of all those trainings. Solar power management and fuel cell operations, asteroid defense as well for telescope and LiDAR data analysis, kinematic impact targeting simulation practices, and laser practice and safety protocols as well. So when it comes to the whole mission, we have to talk about the emergency drills as well, like airlock decompression response, lunar dust contamination cleanup, and medical port operations. And when it comes to lunar fieldwork, regolite sampling and ice mining, because we need water for the habitat as well. Low gravity movement techniques and geology tool use like XRF analyzer and core drill. Mental health resilience is also part of the training, like psychological confinement, 14 days night coping trainings, AI collaborations, have to learn with the voice commands, and conflict resolution and isolation, because we know it's not easy to stay in a close confinement for at least a week or two. So they have to be trained for the conflict resolutions as well. And like for the food, hydroponic maintenance, microgravity lab experiments, and sample preservation and analysis. When it comes to training, they had to go through the basic training for an astronaut. Like they can use NASA exploration missions, all those training modules, training for the moon and beyond, and even they can use 3D printing habitat training video for moon and Mars. They also include JRS Space Architecture series, which talks about designing lunar habitat with Dr. Samir, and he's also part of the Moon Valley Society, so you can go through the video as well. And it also they had to also talk about the and learn for the Vajra asteroid and simulated lunar missions like high sea, Antarctic, and all those things, 3D printing and emergency repair drills as well. So this is all about the training of an astronaut. But when it comes to staying for a week on an whole mission for like limited resources, so we have to talk about the resource for requirement for the 1 week. Like for hygiene, we'll require around 28% of the water capacity. For preparation, around 14%, and for drinking, around 57%. So It can take around the whole drinking, like most of the part of the water will be for drinking and cooking. And for hygiene, we can either recycle the water, and for food preparations also, we need to take care of the contamination and all those things. So water is one of the resources we need to use very mindfully, to be honest, over there. Then comes the food. Like I'm talking about plant-based diets, so brown rice, lentil, quinoa, and even if you're talking about protein, soya protein, and tablets, even you can have a supplements of those tablets as well. For nutrition deficiency, like kale powder is for vegetables and sweet potato flakes, microgreen, fruits and vegetables like bananas and even sunflower seeds, nutrition yeast, seaweed, dark chocolate for people like me who love chocolates. So they can use dark chocolate as a sweetener for them. So total mass of the whole food would be around 12.6 kgs for four astronauts and about 9.8 liters of water for rehydration, and that is for every single astronaut. So the list of, goes for the 208, 2,850 calories a day per astronaut, 100% plant-based nutrition, and 30% lighter than mixed diet could be done with all the raw materials present over there. Then comes the protocols. We need to follow a very set of protocols like daily system check, emergency drills, and data sharing. So these things need to be done by an asteroid researcher for asteroid tracking and update. Then comes sharing the protocols for emergency and all those things. So let's dive deeper on the protocols as well, like daily maintenance. For a system engineer, they had to make sure that oxygen MOX is working clearly. Outputs should be 600 gram per hour, and purity level should be 99.5%. Switch to backup tanks if any fault is there, and alert the Earth monitoring systems. Power grids like solar and fuel cells should have around 45 kilowatt of daytime whole energy. If not, then they have to prioritize wiser for the whole mission, and they can reduce the energy use in the other departments where it is not required. But don't switch off the oxygen port over there. Communication for that, we can use Earthlink as an option. And when it comes to water recycle, we can use recovery rate of water around 98%. So we have to take care of the water recyclers as well. So maintaining that is also required. And manual filtration if it is not being working for a while. Then comes for Vajra Asteroid Tracking Center. So they had to make sure that they are putting the real-time updates. Every detected NEO, which is about 10 meters, have to be uploaded to early warning system of an Earth base, like International Asteroid Warning Network. They have to update them. They have to prioritize objects with 1% of the Earth impact also. Even if the chance is just 1%, they have to inform the Earth stations so they can flag this and they can work on it. Data security as well, like quantum encrypted backups to Earth every 6 hours. We don't want our data to be hacked. Then comes the research sharing, daily reports for lunar regolith properties, microgravity plant growth, and laser test for the deflection and detection of and all those asteroids. And open science policy, like we have to make sure that we are publishing our researches monthly and sharing the data with an open source magazines and all those things. So protocol for safety is one of the main point as well. Like if we are going to have a meteorite impact, we have to make sure we deploy the repair bots as soon as possible if we are hit by any target. And the time to resolve is 5 minutes and even less than that. Because if the impacted place is about the critical instrument like oxygen and even for vacuum and all those things, we have to make sure that we repair the whole system within 5 minutes at least. The boss should be deployed within that time frame. Then solar flares, one of the problems, we have to make sure that if there is an option, we are monitoring the sun as well. So if the solar flares are there, so we have to warn everyone within the 90 seconds of it. Power failures within 2 minutes, and airlock malfunction, if that happens, within 3 minutes, the backup supply should start for oxygen. Okay, so what is a code red? When it comes to a mission and where the habitat is completely on the remote place on the moon, we have to talk about the life support system. If it is not activated 72 hours or survival mode, then it's a code red. We have to make sure that our ration and all the food and power is already there. And if any asteroid hits us, we have to deploy kinetic impactor. It is about to hit it. Okay, it's not after hitting us. Vajra has to confirm that it will hit us, and we have to deploy any kinetic impactors, and we can test also that thing. And also, when it comes to code red, if we have a low oxygen supply, that too also comes under code red. So, when it comes to VR, Earth pods, and occupancy and entertainment, um, we are in a 1 week mission. That doesn't mean we have to do all the research work. We have to talk about the mental health of an astronaut as well in the mission. So we have VR-based spots for 30 minutes of natural, like nature simulation, which we see on the Earth, like forests and oceans, and even sometimes gaming, because most of the people love gaming. So like sometimes it could be a puzzle, memory puzzle in the zero gravity. It could be any sort of VR game, depends on the interest of an astronaut, and sometimes even theaters like weekly movie nights and all those things we can do over here for the entertainment of an asteroid. And like we have to monitor mental health of an asteroid also. So I hope doctors will be able to do AI therapy sessions like mindpal over there, monitoring the stress via voice and vital analysis of an astronaut. And if anything is diagnosed, they can suggest the tailor meditations according to the symptoms. Conflict mitigations also, so mandatory unity dinner. Like if there is a problem between the crew and staff, they can have a unity dinner and where they can resolve not just their hunger but their issues as well over there. And they can log whatever is going on in the whole mission. So the logbook could be also one of the good things to understand all those things, what is going on, what is the problem, how we can resolve it, and all those things. And even for the physical wellness, the therapist can also do some low gravity yoga sessions and VR sports sessions for an astronaut to stay healthy and be safe from all those problems which are going to be part of the um, high radiation issues like lower muscle count. So when it comes to the whole mission, um, it's not just about what is going to be on the moon. The spin-offs can be one of the good things to talk about over here, like Rego shields, which are the radiation tiles, which is going to be printed in the engineering sector over there. Material used will be 90% of the lunar regolith and 10% recycled astronaut urine, which can be like urea for the binder. Purpose of it is to modular wall panels for habitat expansion and radiation shielding. Printing process could include regolite harvest for the rovers and uh, to have a solar concentration of about 1,000 to 200 degrees centigrade. And step two will be urea-based binders, layer by layer for the structural integrity. Step three is robotic arms assembling the interlocking tiles, and the advantage could be locking around 85% of the cosmic frames, and that is also lighter than the Earth's concrete. So that could be a good option for concretes. Then comes the biogrid, one of the custom tools we are going to make for the moon mission. It is going to print the medical and labs used in the medical and lab sector around 70% recycled PLA for packaging and 30% moon dust fillers. Purpose it's for the purpose agronomic tools for low gravity use like wrenches, scalpels, and even sample collectors. So how the process will work? They had to actually melt the recycled plastic with the lunar fillers to strengthen the material. Then they have to print with the magnetic grip for the tool retention and the in the low gravity. Then comes coating with antimicrobial nanolayers. And advantage of this could be 50% lighter than Earth's and resistant to lunar dust problems as well. And the third one is the Luna brick, which is going to be the construction, which is going to be used in the construction, like printing the exterior construction sector of the habitat. Material used over here is 100% compressed regolith and microwave glass from the lunar sun. The purpose of it is to rapidly build the infrastructure buildings like landing pads, observatory shields for the future missions. And printing process includes like solar power microwave melts the regolith into glass bricks. Then drones, which can be used for stacking bricks using regolith motors, waterless adhesives, and then step
Have we lost her?
Yes. So when it comes to all the technologies which is part of the whole mission, the spin-offs are also similarly great, like construction materials and constructions and all the materials used for the mission. Lunar 3D printing can also help in the resilient housings on the Earth. Using 3D printed homes can be used by the volcanic ashes instead of lunar regolith for the mission. And the advantage of it is it's fireproof and 60% cheaper than the concrete itself, and it can help in the affordable housing process. Regolith over here can be used for zero cementing concretes like Soul Crete. I have written the name. Uh, it could be carbon neutral construction, which can help for reducing the carbon footprint of humans on Earth. And the advantage of it is reducing the global carbon dioxide emissions by 8% because of the cement industry. Then comes for the energy and environment, the spin-off from the energy and environment systems used for the whole Lumen project could be used on Earth for industrial carbon capturing, like terramoxine, where you can convert whatever carbon dioxide being released to convert into oxygen. And the output could be 1 ton carbon dioxide per day, which can be converted into carbon credits, and that can also help the people who are working in this industry. And also waste to energy like sunfroch, where we are talking about vaporizing landfill waste into Senegas, like used for cooking and all those things. And food and agriculture, where we are talking about growing foods in urban setup where you don't usually see the large lands where you can grow foods like on the farm usually. So lunar hydroponics can be used as an herbal vertical farming as well, where you can grow your own microgreen towers and reduce the whole dependency on the chemical-based food. 90% of the less, 95% less water will be used and no pesticides. So it is also safer for your health. And LG bioreactors can be used as in carbon negative protein over here, where you are talking about LG Pro, like protein powered carbon dioxide emission. You can use protein powder for carbon dioxide emissions. And advantage over here is more efficient soya farming. So, in total, when we are talking about what SDG goals we can achieve with this, so SDG 9, 13, 3, and 2 and 6 as well. With the 9 SDG, we can talk about 3D printing regolith, which is used for the lunar habitat. And on Earth, we can use it for affordable housing, and which can affect around 1 million house per build. And for SDG 13, we are talking about MOXIE, that is in carbon dioxide oxygen converter from the carbon dioxide, which can capture the carbon dioxide and reduce the 1 gigaton of carbon dioxide per year. With the SDG goal 2, we are talking about aeroponics, where urban vertical farming can achieve with this, and which can reduce our dependency on the field and can feed around 10 million people a year. Then with SDG 6, we are talking about water recyclers, and it can generate around 100 liters of water for every day. So when it comes to the research, one of the topics included in this presentation is what sort of research we are going to do over there, apart from the whole Vajra Astronomic Center. So we are going to talk about the low gravity biology over there, how the 1/6 gravity of the moon affects the multicellular organisms, and even that can help us to understand the gravity of the Mars as well, and how we are going to sustain over there, growing human organs, and even sometimes we are talking about plant root systems in the variable G centrifuges, and monitoring gene expressions and the changing of change with the changes of the lunar spinach and Earth-based finish, and the impact could be preparation for the mass agriculture. How you're going to talk about the mass terraforming over here, revealing the gravity thresholds for the human health. Then the second research topic is about the closed loop food system, where we are talking about hydroponics, wheat growth with in oxygen and carbon dioxide, oxygen exchange loops, and it have to measure around 30 days of crew survival on the 80% bioreactors. Impact could be blueprint of Martian city and famine resilience on Earth as well. And when it comes to the third one, that is in-suit propellant production. We need propellant for the future missions as well. So mining lunar ice for hydrogen and oxygen to use it for the rocket fuel, like test. We can also test our electrolyzers with a target of 98% of purity and enable us for the Mars missions, carbon-free aviation fuels on the Earth as well. So that's about the management and all those things and how all the support systems are going to work. I've already discussed in detail. So life support system like oxygen production and water recycling will be used for our use of 100% water over there, like monitoring urine and humidity, hydrogen water, H2O purity. It should not have the contamination even for zero point 0.1 micrometer. And if there is, there should be an alert for the filter replacement. Then comes power management. We are going to use solar arrays like solar panels and all those things. Energy is prioritized for the Vajra first, and then life support, and then 3D printing during the outage of the energy supplies. Battery is required to extend around lifespan of 300% over here. And 3D printing and manufacturing, regular printers will be used, and material recycling, like we have to guide the robots for salvage scraps for the reuse. Then crew health, like I mentioned, Medibot will be used to analyze, like it's a wearable device which is going to talk about the heart rate, radiation exposure of an astronaut. And it could all, we have to suggest like VR therapy if the stress markers are very high. And the radiation shelters are also required for the solar flares and have to seal the shields zone as well. For entertainment purpose, we have VR time allocation and emergency responses. For that, we have fire, like seal modules, and even guide crew via AR overlay to safe zones. So the format, if we want to improve the quality of a life of an astronaut on the lunar habitat, like Astro Diaries, they can monitor all the daily activities. 5 minute could be a voice, or like the current era, we are doing vloggings. So we can use the vlogging of the whole mission as well. And low scientific moments like, oh, that's wonderful. We found something new over there. That could also be part of it. And like graphic novels, sometimes I like doing some graphic work. So I've included some graphic novels as well. A Day on a Luna, where an asteroid we saved, and all those things you can use for a uh, comic version from the Luna habitat as well, human. And there could be a sci-fi microfiction from the Lumen habitat from the astronauts also, like 200-word stories imagining the life of the astronaut in 260 lunar cities, first contact via virtual signals and all those things. So this can improve the quality of life of an astronaut on the station. And with that note, these are the references I have used, and that's about me. I hope you like the presentation. I'm open for the questions.
Very good.